Hello viewers, in today's session we are going to discuss another very important and conceptual problem from limits. And here we are going to discuss this problem in which a function f of x is defined as f of x is equal to x if x is an integer, and f of x is equal to 0 if x is not an integer, and we have to find the limit x tends to 2 f of x, right? So before finding out the limit x tends to 2 f of x, let us first understand this function. Now see here, this function f of x is defined as a piecewise function. So f of x is equal to x whenever x is an integer, that is x belongs to the set of integers, and the set of integers is given by -4, -3, -2, -1, 0, 1, 2, 3, and so on, right? So whenever x takes an integer value, that is, suppose x is equal to -1, then f of -1 is given by -1, right? Similarly, when x is 0, f of 0 is given by 0, and when x is say 10, then f of 10 is equal to 10. So f of x is equal to x implies that the image of -1 under this function f is -1. Similarly, the image of 0 is 0, the image of 10 is 10, right? So whenever x belongs to the set of integers, then f of x is equal to x, right? Now let us consider the second part. Now here we are given that f of x is equal to 0 if x is not an integer, that is, x does not belong to the set of integers, and here the set of integers is given by this set, right? So if x is say 1.2, right? Now 1.2 is not an integer, right? So what is the value of f of 1.2? It means the image of 1.2 under f is equal to 0. And similarly, if we have say x is equal to square root of 2, now square root of 2 is an irrational number and it does not belong to the set of integers. So the image of f of square root of 2 is again a 0, right? And similarly, if we take say x is equal to minus 3.3, then the value of f of minus 3.3 is equal to 0, right? So this is the meaning of this function f of x, right? Now let us find out this limit. So to get the value of this limit, what we will do, will first find out the right hand limit and then the left hand limit. So if the right hand limit exists and it is finite, and left hand limit exists and it is finite, and both these limits are equal, then we can claim that this limit exists, and the common value of RHL and LHL is equal to the value of this limit. So now here we have this point, that is x is equal to 2. So when we approach x is equal to 2 from the right of x is equal to 2, then we'll calculate the right hand limit, and when we approach towards x is equal to 2 from the left of x is equal to 2, then we calculate the left hand limit, right? So when we approach from right hand limit, then we have a point in the right neighborhood of x is equal to 2, and this point is given by 2 plus h. And when we approach from left, then we have a point that is very close to x is equal to 2, and this point is given by 2 minus h. And remember, this h is a very small quantity which is known as infinitesimally very small, and this h is a positive quantity, right? But h is greater than 0. So now the right hand limit is given by limit. The notation is limit x tends to 2, and here we write a positive sign, and here we have f of x, right? Now we take x is equal to 2 plus h. So 2 plus h is greater than 2. It means we are towards the right of x is equal to 2. So when x approaches to 2, then h tends to 0. So this limit is now limit h tends to 0. We are now transforming this limit in terms of h. And here we have f of x. For x we can write 2 plus h. So now we have limit h tends to 0. Now see, this expression suggests that we have to find the value of the function f at this point, that is x is equal to 2 plus h. Now 2 plus h. Now see, 2 is an integer, right? And h is not an integer. So 2 belongs to the set of integers, but h does not belongs to the set of integers. So this sum, that is 2 plus h, is not an integer. So here this is an important thing to note, that is 2 plus h is not an integer, because h is a very small quantity which is not an integer. So when we add integer to a non-integer, then the sum is not an integer, right? So the value of f of 2 plus h should be equal to 0 due to this definition of f of x, that is f of x is 0 when x is not an integer, and here x is 2 plus h, right? So f of 2 plus h must be equal to 0, because 2 plus h is not an integer. So here the value of f of 2 plus h is 0. So we write 0. So this limit is equal to 0. So the right hand limit is equal to 0. So now let us find out the left hand limit. Now the notation for left hand limit is limit x tends to 2, and here we put a negative sign, and here we have f of x. Now we'll take x is equal to 2 minus h. So when x tends to 2, then h tends to 0. So now this limit is limit h tends to 0, and we have f of 2 minus h, right? Now again we can make this similar argument here. See, 2 minus h. Now 2 is an integer and h is not an integer. So if we subtract this h from 2, we'll get a non-integer, which is not an integer, right? So when we subtract two numbers out of which one is integer and other is non-integer, then the difference must be a non-integer. So 2 minus h is not an integer. So again, by the definition of f of x is 0 when x is not an integer. So 2 minus h is not an integer. So the image of 2 minus h under f is equal to 0, because 2 minus h does not belongs to the set of integer, right? And 2 plus h, which was considered while calculating the right hand limit, 2 plus h does not belongs to the set of integer. So f of 2 minus h is equal to 0. So now this limit is the limit h tends to 0, and f of 2 minus h is equal to 0, right? So here we have 0. So the value of left hand limit is also equal to 0. So from this discussion, we have seen that the right hand limit, that is limit x tends to 2, here we have a positive sign, f of x is equal to 0, and the left hand limit, that is limit x tends to 2 minus f of x is also equal to 0. And we can see that both the limits exist and they are finite, and moreover right hand limit is equal to the left hand limit, and both the limits are equal to 0. So we can now conclude that this limit, that is limit x tends to 2, f of x is equal to 0. So the value of this limit is equal to 0. So this is how we can solve these kind of problems related to limits.